So now in this video, we're going to talk about an important topic that pops up from time to time and is probably kind of confusing until obviously you understand it. So we'll zoom in. The first premise is we want half of the supply voltage. We can take two equal value resistors. I'm going to use 10,000 ohm resistors right there. And you put 10 volts across the two resistors where they meet in the middle. You'll get half of the supply voltage. But that cannot power the load because the load now is pulling the voltage closer to ground right there. So once you attach the load, it actually sucks down the voltage at this point. It won't be 5 volts anymore. And, you know, that current has to go through a 10K resistor in the load and everything. So we can measure, you know, the voltage there if there's no load. We can measure the voltage with the load as well. But in any case, it's not going to maintain the voltage if you draw any current from it. So that is where a voltage follower comes in. When it comes to the NPN bipolar junction transistor, I'm going to use the 2N3904 in this video. It takes the voltage to the base. With the bipolar junction transistor though, you do get about a 0.6 volt shift approximately right there. So we set 5 volts at the base, but we're probably going to end up with about 4.4 volts or so at the emitter right there. And so we'll be able to power this, and you know, it's approximately what 5 volts would do right there. And so we could adjust this, get slightly higher voltage or whatever. We could also use an op amp to get exactly what we put to the input when it comes to voltage follower. But op amps can't provide as much current. So a lot of times you'll see a transistor instead of the op amp, or maybe the op amp controls the output voltage of the transistor. An even more complex circuit. So there's more complex options. We're looking at one of the more simpler ones there. So there's the schematic right there. We have the 5 volts coming in the base. We're going to get about 4.4 volts out. But, you know, you just need a very small trickle from base to emitter. That's where the amplifier comes in. We have the signal here. We are transferring the signal, but we're amplifying how much power it can provide. So once a little bit of current starts flowing there, wants to flow, a lot more current will flow collector to emitter. Ultimately, the amount of current going base to emitter will stop increasing once the collector current is big enough to get our voltage minus about 0.6 volts right there. And so it just works out where you end up getting the base voltage minus 0.6 volts across the load, even though there's higher power demands. So yeah, we'll zoom over here, and I'll move the power supply over there. And you know, I wired up both circuits there. We got 10 volts there. So we're trying to put 5 volts across that LED and trying to put 5 volts across that LED, even though we realize that we got about a 0.6 volt drop right there. But yeah, there you can see huge difference in how bright they are. Probably much less than 1 milliamp of current over there. And we'll put this back. So yeah, basically all the current you see on there is that LED, unless it was right borderline, like if this would have dropped down to like 9.99 or something, then it would say 10 because it's not as accurate. But yeah, there you can see the difference right there. So you can't usually use a voltage divider to directly set a voltage across a load. You'd have to have like relatively low value resistors as a voltage divider and a load that barely needs any current. Generally that doesn't happen very often. So usually you have an amplifier, and here is one option, the NPN bipolar junction transistor, which is probably the first version of the voltage follower you come across. Again, it's not perfect. There's op amps that deliver voltage better. But if you need more current, then you may want to use the transistor by itself, or you may want to use the op amp and transistor together. And of course, it's good when you're learning these things to actually take a multimeter and measure the stuff for yourself. So I don't have to move the red probe for anything except for high current, more than about 0.6 amps. And voltage, there's no range setting. I just set it to V. If there's numbers, you set it to a number voltage higher than you could expect, so higher than 20 volts. But we don't have that here. It auto adjusts on its own right there. So yeah, first we can take a look at the supply voltage, and it may be a spec below 10 volts right there because we got a little resistance and stuff along the way. And so we got that. First, let's well, we got the power on. I can go anywhere where the negative supply is there. Now I'm going up to where the LED is, and then you can see we got about 1.87 volts. So that's basically the forward voltage of the LED. A little bit higher than that, because some of the voltage is across the resistor right there, and so hardly any. 220 ohm resistor, you can calculate how much current is flowing through there. Current flows equally through components, and there you can see we got the rest of the voltage across the LED. Now I'm going to remove the LED, and so I can go anywhere where ground is, doesn't matter. I don't have like a real solid spot. And there you can see now we got our basically 5 volts out of 10. So the load throws that off. It's not a strong 5 volts at all. Now we're going to come over here. First, let's look at the voltage across the LED. As I said before, it's probably going to be about 4.4 volts across the LED and resistor. So approximately, there you can see it is lower, but it's in that range right there. That's not a perfect number. There's some variables that will throw it off. But in any case, we should have 5 volts right here. And there you can see it's a speck lower than 5 volts. But again, we do have like some losses and stuff. So not perfect. And that probably explains too why we have 4.2 here instead of about 4.4. So there are variables. But there you can see we got that. And again, the voltage is going to go across. We got a lot more voltage across the resistor there. It looks like maybe 15% or 15 times, I mean, as much voltage across this resistor as we had across the other one. And maybe closer to 20 right there. So a lot more current. We can measure the voltage across the LED. It'll be the rest of the voltage. So what was that, like 2 more volts? Yeah, 2 volts right there, which we expect when there's about 10 milliamps of current flowing through a red LED. Blue LED or green LED would build up about 3 volts across the LED and less across the resistor right there. But again, let's go back to our voltage divider right there. And I think I was short. Oh, there we go. I wasn't measuring in relationship to ground. We had some different voltage range right there. But yeah, 4.8. Let's see what it is when we remove the transistor. And there you can see about 4.9. So it did affect the voltage a little bit. But we kind of expect that because it was still drawing a little bit of current. To maintain the voltage better, we would use an op amp. So now, in summary, we can easily get, a fraction of the supply voltage with voltage dividers, but when you draw current from that voltage divider, it's going to throw it off right there. So you want to draw basically as little current as you can, but if you can afford to throw off the voltage a little bit, like we can in this circuit, that red LED is plenty bright right there, then you can use a simple solution that draws a little bit of current there. But if even that is too much, then there are options, typically an op amp, where you can get basically the exact voltage transferred to the load if you know what you're doing. So you keep adding to the circuitry to overcome the weaknesses of one component by using the strengths of another component in combination. But we got kind of the simplest version here. So I used a 2N3904. There's the pin layout. Left pin is the emitter, down there arrow, base and collector. And so when I put the flat side to the right there, we got the emitter to the LED, base to our voltage divider, and collector. There's a little orange jumper right there going to the positive supply for the top pin. So that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see ya in the next video.